Right now, there is a place in the universe where the rules you have trusted your whole life simply stop working. A place where time slows to nothing, where light cannot escape, where the floor of reality falls out from under everything. It is called a black hole, and it is not science fiction. There are millions of them scattered through your galaxy, and one sits at its very center, 4 million times heavier than your sun. So, let me ask you something. What would actually happen if you fell into one? You probably picture a violent, instant death, a scream, a flash, gone. But the truth is so much stranger than that, and to understand it, you have to forget almost everything the movies told you. Start here. A black hole is not a hole. It is not an opening, not a tunnel, not a drain. It is an object, a place where so much mass has been crushed into so small a space that gravity becomes overwhelming. Pack enough matter tightly enough, and you bend the space around it so severely that not even light is fast enough to climb back out. And light is the fastest thing there is. The boundary where escape becomes impossible has a name: the event horizon. Cross it, and there is no path back to the universe you came from. Not because something is stopping you, because every direction that exists inside now points inward. For a long time, this was only mathematics, a strange solution to Einstein's equations that even Einstein himself doubted was real. Then, in 2019, a planet-sized network of telescopes called the Event Horizon Telescope did something astronomers had dreamed of for a century. It took a picture, a real image of a real black hole in a galaxy called M87, 55 million light-years away. A dark circle, ringed in fire. After all the theory, there it finally was. A shadow the size of our entire solar system. So now imagine you're falling toward one. Picture yourself drifting in the black, feet pointed down toward a perfect dark circle ahead. At first, nothing dramatic happens. This surprises people. You do not feel the pull the way you feel a roller coaster drop, because in free fall, gravity feels like nothing at all. You're simply floating, the way an astronaut floats, watching the dark grow. But the black hole is pulling on your feet slightly harder than on your head. They are closer, after all. With an ordinary planet, that difference is too tiny to notice. Near a black hole, it grows, and grows. The physicist Kip Thorne, who won a Nobel Prize for his work on these objects, gave this effect a perfect name. He called it spaghettification. Your feet fall faster than your head. The difference stretches you. Gently at first, then without mercy, until you're pulled into a thin strand of particles, longer and thinner, drawn down toward the dark like water circling a drain. For a small black hole, this would tear you apart long before you ever reached the edge. But here is where it turns strange. Truly strange. For a giant black hole, one of the monsters at the heart of a galaxy, the stretching near the edge is gentle. You could cross the event horizon and feel nothing at all. No wall, no barrier, no flash. You would pass the point of no return without a single sign that the most important moment of your existence had just occurred. The universe would not announce it. You would simply be inside and not know. Now, pull back, step out of your falling body, and watch yourself from a safe distance, far away, holding a telescope. You would see something that should be impossible. As your falling self approaches the edge, you would appear to slow down. This is not an illusion. Near a black hole, time itself runs slower, an effect Einstein predicted, and which scientists have since measured even here on Earth, where clocks at sea level tick slightly slower than clocks on a mountaintop. Closer to the black hole, the effect becomes enormous. So from the outside, your falling body would seem to freeze, hovering at the edge forever, your final seconds stretched across eternity. Your image would redden, dim, and fade, like a candle running out of air. And you would never, ever see yourself cross. But from inside your falling body, none of that happens. You cross in a heartbeat. One reality, two completely different stories, both of them true. Which one is real? They both are. The universe, it turns out, does not owe you a single answer. Now zoom all the way back, out of space entirely. Back to your bedroom ceiling. You're not falling into a black hole. You're lying still, reading this, your feet warm under a blanket, the most ordinary night imaginable. And yet, the same force that would stretch you into a strand of light is the force holding your body to your mattress right now. The same gravity, the same law. Just gentler. The thing that would destroy you at the center of a galaxy is the thing tucking you safely into your bed tonight. And here is the twist that astronomers never saw coming. For most of history, black holes were imagined as pure destroyers, cosmic monsters that swallow everything and give nothing back. But over the last 50 years, that picture has completely flipped. The supermassive black hole at the center of your galaxy did not just consume, it helped build. Its gravity is part of what gathered the stars into the great spiral you live inside. And the dramatic deaths of massive stars, the very collapses that create black holes, are what forge and scatter the heavy elements across space. The iron in your blood, the calcium in your bones, the oxygen filling your lungs as you read this line. You were assembled from the wreckage of dead stars. The same violent universe that builds black holes built you. So the next time you feel small, remember what small actually means here. The atoms in your hand are billions of years old. They were cooked in stars that died before the sun was born, scattered across distances your mind cannot hold, and gathered, against impossible odds, into something that can look up at a black hole 55 million light-years away and understand what it is seeing. Cecilia Payne-Gaposchkin, working a century ago, was the one who first proved what stars are truly made of. Hydrogen and helium, the same elements still falling into black holes today. She showed us the recipe. You are the result. A black hole is the closest thing the universe has to an ending, a place where time stops and light surrenders, and every path leads inward. And yet you, a soft and temporary arrangement of stardust, can sit in a warm room and hold that ending in your mind without being touched by it. You will never fall into a black hole, but you're already falling. Through space, around your galaxy, forward through time, toward your own quiet horizon that you cannot see coming and will not feel arrive. So let me ask you again, now that you know what waits out there. Right now, there is a place in the universe where the rules you have trusted your whole life simply stop working. And the fact that you, made of dead stars, on a small blue world, can understand that place at all, may be the strangest and most beautiful rule of them all.